Hello, my name is Ken Holman, and I want to thank the organizers for this opportunity to present a paper I delivered at the JATSCon conference in 2023. This paper highlights the fidelity and flexibility available when using XSLT and XSL-FO in single source publishing in a way that is sustainable. This is the address where you can find the paper posted in the conference proceedings. Today's presentation is just a very quick overview of the principles of sustainable single source publishing. There are other details that you will find in the paper, but for the purpose of today, I'm just going to review sustainable single source publishing. We've seen this diagram many times. The objective of single source publishing is to reduce the creation process of multiple renderings of a single concept, a single creation, by having the content in an XML format that is published multiple ways. The content is only created once. There are fidelity challenges when having parallel creation processes because you may change one of the outputs but not the other. And there's also the maintenance issue of having to maintain parallel creation processes for the outputs that you need. I've drawn 3 outputs here because these are the outputs needed by my clients. So in single source publishing, a single document is created and that document is passed to a publishing process to produce the outputs. But in many ways this is unsustainable because we have similar challenges for fidelity when we have separate transformations producing each of the separate outputs even from a single input. This is a very common design pattern where you have common fragments that share logic between the different transforms, but each transform is targeted for the different outputs. For PDF output, the transform is creating XSL-FO. For XHTML output, the transform does that directly. And for docx output, the tool that we've used is called Wordinator from Elliott Kimber, and the XML format for Wordinator is the simple word processing XML. And so the transform takes the XML input and produces SWPX for producing docx. Well, we still have a fidelity issue because these transforms each have to be maintained, and if you change one transform and not the others, you then have a fidelity issue with the output. But there's also a maintenance challenge when doing it this way because the semantic interpretation of your source XML has to be copied in each of these transforms, and if you have a semantic issue, instead of just a presentation issue, if you have a semantic issue, you have to remember to maintain those issues in all 3 of the transforms so that you get the same result in all of them. So looking in detail at these 3 transforms, here on the left we have a standards construct called the section, and we are producing PDF, XHTML, and docx for that section. For the PDF output, we create XSL-FO with blocks. For the XHTML, we do a transform, a semantic interpretation of the standard construct into divs and classes. Divs, spans, and classes. And for docx, we have a transformation of that structure into SWPX that is interpreted by Wordinator to create the output. This is the name of a DOTX style that is associated with this word processing paragraph. To make this unsustainable approach sustainable, At Rialta, what we do is we chain transformations from the XML input, producing XSL-FO as the initial interpretation of the standards XML in an XSLT transform, but this FO is very richly annotated with foreign namespaces, and in those foreign namespace constructs we have cues that are interpreted by an XSLT transform, since XSL-FO is an XML document, and that transformation interprets the cues into XHTML output, which itself is XML, and so we pass that into an XSLT transform to produce the SWPX. One thing to note about how our requirements ended up fitting this design pattern is that the XSL-FO is highly structured. You have a lot of nesting of constructs, and the FO understands the pages and the blocks inside and the blocks within blocks, whereas the XHTML is very flat. And so this transformation flattens the deeply structured FO into a shallow structure, XHTML, as is required for the browsers. Well, it turns out that docx files also are very shallow and very flat. And so it was quite straightforward to work from the flat XHTML into SWPX in order to reflect the requirements for producing the docx output. But where this becomes very maintainable is that the semantic interpretation is done only a single time in the production of the XSL-FO. This is the only time where I have to think about what is a list, what is a section, what is a figure and its captions as expressed in the XML for a standards document. The cues that are in the FO are mechanically transformed into XHTML. I don't need to know how standards documents work in order to mechanically transform those cues into the XHTML. Similarly, it's a mechanical transformation using mapping tables to go from the XHTML and CSS into the SWPX and the DOTX styles. This addresses the important fidelity issue because the content of the standards document is put into the FO a single time. And it is that content in the FO that is placed on the page in the XHTML. And again, that content is placed onto the page in Word because it is the same content that was in the FO. We are not going back to the standards document and trying to lay out the content in each of the outputs. It's the same content, once going into the FO and then copied into the XHTML and then copied into the SWPX. Here is an example of that section element as before being transformed into blocks as is required by XSL-FO, but you can see here the annotation X:(H). This is in a foreign namespace. It is ignored by FO processors, and I have encoded this H attribute with the name of the XHTML construct and the name of the CSS style. The mechanical transformation works off of the cues and produces the XHTML document with a div from here and the style name from here for all of the constructs. And I've just ensured at this transformation time to put in every cue I need for the XHTML at that time, so that when it comes to producing the XHTML, it can produce it entirely from the cues that are embedded. Similarly, these constructs are transformed into the SWPX, and there's a mapping table that maps the client's use of the CSS style to the DOTX style. Looking at the data flows inside Rialto's publishing system, there are 3 inputs and there are 5 outputs. There are OASIS technical committees that have DocBook documents that need to be transformed into DocBook outputs for the use at OASIS. But these same documents for some committees have to be published at ISO. And so in the Rialto publishing system, I transform the DocBook XML into NISO STS for the publishing chain. There are also legacy ISO STS documents that need to be published, and these are transformed into NISO STS, and that publishing chain works for all of the 3 inputs. The publishing chain, as described before, produces XSL-FO for PDF files. It produces XHTML, copying in the CSS and the figures so that this is monolithic XHTML. There are no external references to graphics or CSS files, which itself is transformed into SWPX, making reference to the styles in a DOTX file that produce the docx output. This contrasts the 2 approaches to single source publishing because the DocBook style sheets themselves are parallel publishing processes. One set of style sheets to produce the PDF and a second set of style sheets to produce the XHTML. Contrast that to the STS publishing chain, where there is the single semantic interpretation and then 2 mechanical interpretations as described before. The DocBook style sheets are well engineered to be maintained in parallel, but there are still challenges. This is the include tree for the DocBook style sheets for producing XSL-FO, and this is the tree for producing the HTML. The engineers have used the same file names in these different directories so that everything can be compared to make sure that they are done in a parallel fashion, and both fragments make reference to a common XSLT that can be shared in order to produce the similar results on the way out. And I say similar, not identical, because it's still up to the engineers to ensure how they interpret the FO is the same as the way they interpret the HTML in order to have fidelity in the output. Here's an example from lists.xsl of the FO needed to present a list and the HTML needed to present a list, found in the like-named lists.xsl in the different directory. If I have to make a change here based on the interpretation of the DocBook XML, I have to be sure to make the same change here. Whereas in the Rialto list processing, there is one template match that produces the XSL-FO and all of the cues needed for the XHTML at this time. I have encoded in the H attribute of the X namespace the name of the HTML element, an asterisk, and the name of the CSS class. That allows me to do a mechanical transformation of the XSL-FO that was created into the XHTML that's needed, and following along from that into the docx. Thank you for your attention to this very quick overview of this paper. I invite you to find the paper here. This is so important for Rialto because of our growing customer base. We want to be able to leverage as much as we can in a single interpretation of the standard semantics in order to produce all of the outputs. Thank you again to the organizers.